Well, hello. I want to talk briefly a little bit more about perceptions. Now, if we were in class together, we would do a very simple lab. We would have done it the first day. I call it the observations of a burning candle. And I want to give you a little background on that and understand that when you make observations, your observations should be like you're using words and trying to paint a picture so that a person who was blind would be able to see what you're talking about. So these observations that we come up with, we're going to learn can be both qualitative or quantitative. If they're quantitative, they will have numbers associated with it. If they're qualitative, they won't have numbers. For instance, if I said, well, she's 5'2" and 408 pounds. Now, you might think, wow, that is a big person. Well, actually, I'm referring to an adolescent elephant. So again, you heard the words I gave, and then you made your own jump to what I meant. Your perception was I was talking about a person, even though I clearly was not. All right, well, let's get into this little PowerPoint. I told you I want to keep it somewhat short, and I will try to do my best on that one. So here we go. This is actually a rather lousy cartoon. It says, well, I see you finally met your match, and the little candle's all burnt out. What is this about? Well, what I wanted to do was to have you make an observation of a candle and try to come up with 30 observations of a candle. And you have to come up with half of those observations before you light the candle. And they can be qualitative or quantitative. That's what the activity is that we would have been doing in class. So you think that sounds impossible. Well, let me share with you just a few observations here. So we have here our little candles burning. So it says the candle is cylindrical. And then it says it has a diameter of about 3 centimeters. Now, is the diameter of 3 centimeters, is that qualitative or quantitative? You guys speak up. I didn't hear you. Qualitative? No, it's incorrect. If there's a quantity like 3 centimeters, then that's quantitative. The candle is cylindrical. That would be qualitative. The length of the candle was initially about 16 centimeters, and it changed slowly during observation, decreasing about 1 centimeter in 1 hour. The candle is made of a translucent white solid which has slight odor and no taste. Now, we know we shouldn't taste in the lab. It is soft enough to be scratched with a fingernail. There is a wick which extends from the top to the bottom of the candle along its central axis and protrudes about 5 millimeters above the top of the candle. The wick is made of 3 strands of strings braided together. I've already come up with 17 observations. Now, sometimes the observations may not be obvious. The burning candle makes no sound. Now, you think, well, that's a dumb observation. Well, look, I might have pajamas that are flame retardant or don't burn easily. That might be an important thing to note. It emits yellow light, bright but not blinding. Again, this is just an example of what careful observation can be. The other thing we would have done if we were in class is we would have watched a little chemical reaction I refer to as the Remsen reaction. Now, I have a video of it. It's a little bit long, so I have it shortened up for you, and so we can kind of see what happens here. So initially, I have what's called a Florence flask over here, and I have a tall form beaker, and they're attached with a bent piece of glass shoved in a rubber stopper. There's a liquid maybe in the bottom here, can't tell, and this liquid over here is pink. So what I want to do is I'm going to take the lid off of here, and I'm going to drop 2 pennies into that container. After I drop the 2 pennies in the container, I'll seal it back up. Now, immediately those pennies start to what looks like boil and bubble. There's a green liquid being formed at the bottom and a red-brown gas being formed inside. Now that gas bubbles over to the pink liquid. It's now changed the pink liquid to colorless, and now it's starting to create a siphon, and it sucks the liquid back in until finally all the liquid's gone. Now this demonstration takes about 10 minutes in real life to see. And I never tell students what is actually happening. But most of the time, all of my students are watching, trying to figure out what's going on. And I tell the students, if you honestly don't care what's happening there, then you should probably choose business as a major in college, because your interest is making money and you're not necessarily a curious individual. Nothing wrong with that, but science is generally reserved for people that are curious, that want to understand things and find things out. So if you're the type person who you need to look things up, when somebody tells you something you don't understand, you go home and you read a book or you look it up online, then science might be just up your alley. All right, I just want to have a brief little talk about that, and we'll stop the video at this point.